This is a follow-up video to that introduction on how to do conversion problems, where we saw to kind of start, you need to deconstruct the word problem to know kind of where you're starting, where you want to go, and what is the connection point, the boxcars that go in the middle. You may want to watch that introductory video on doing conversion problems before you get to this one, but thankfully, this one's pretty easy to do. So remember, we have kind of the building a ratio type of approach to conversions, like when you're dealing with density, we have to put one number over another number and find a ratio. You have changing a ratio, and we also have using a ratio along the way, i.e. dimensional analysis. This one's pretty straightforward in terms of how we're going to deal with it, because it's really just looking at, if we read it, it says the distance between two oxygen atoms in an oxygen molecule. So you kind of want to be able to put that together, that we have, I'm just going to put it in the corner, an oxygen molecule. It's an elemental form of oxygen. We learned that it has the same atom. It's just an elemental form. It's in the molecular form of that element. But we have to know the distance between it, not in terms of centimeters. They give us that. It's a given. It's going to be our starting point. This is going to be a starting point for us. But it wants us to use a ratio, 2.54 centimeters to inches, 1 inch, to get to the measurement in terms of inch. So we can do one of two things. We can use the ratio along the way, and I'm going to have other videos for that. But we can also just use sort of changing the ratio type of approach, where we have like A over B is equal to C over D. That's often, again, what students enjoy doing, these types of problems. We're just changing the ratio, where the ratio given, let's say for this in case, is this ratio here, 2.54 to 1, and we just expand or shrink the ratio. In this case, we're going to shrink it because we're going much further down in terms of centimeters. So let's do it. Let's put it right in the middle here. Let's take our given, and we're going to say I have, and I'll put this in blue, I have 2.5, I'm going to put inch on top here just for reasons later on. So I have 1 inch on top for that A, and I put, that's my A, and then I'm going to have 2.54 centimeters on the bottom. And that's, again, this is a given ratio that I can now expand or contract. And what do they give us as information? Well, they tell us we have now a distance between oxygen atoms in the molecule that's 1.21 times 10 to the minus 8 centimeters. So where do I put that on the other side? Well, you better put it on the bottom, because the units have to be the same. If we're going to have apples to apples and apples to apple, apples to oranges, so to speak. So let's put that 1.21 times 10 to the minus 8 centimeters on the bottom. And then we have on the top our x, what we're looking for. What is the distance in inches? Now, if we do the math, and you should be able to take this number and move it to the other side by multiplying both sides by this number. So if I put that number right here, don't have space, it would cancel. But if I put it over here, I'm going to bring it on down, that'd be 1.21 times 10 to the minus 8 centimeters times 1 inch over 2.54 centimeters, still on the bottom, is equal to x. We've just rearranged, put it in red here, we've rearranged this equation to isolate x. How did we do that? We multiplied both sides by 1.21 times 10 to the minus 8 centimeters. And of course, it cancels with this side. That's what happens when you multiply that in the numerator. The denominator and the numerator go away because it's the same value, and we're left with x. But over here, it doesn't go away. Now, one thing we should notice, the unit goes away, and now we're just going to be left with the math. And what you can do is a little trick here. Instead of putting in scientific notation on your calculator, you can hang on to the 10 to the minus 8. And just do the 1.21 divided by 2.54. And we know it's going to be a smaller number because this is smaller than the 2.54. So let's do that. We can say, well, I'm going to take 1.21 divided by 2.54. And it equals. Now I'm going to write that down on the right side here. It's kind of in my box. That's my final answer. I'm going to put 0.0 Now I need to watch my sig figs. I have 3 sig figs in this measurement that they started with, 1.21. This is a given ratio conversion factor. You do not limit your sig figs by a given conversion factor. We limit it by the measurement that we have here. So that's 3 sig figs. So I look at my calculator, I see 0.47637. So this is going to round down to 0.476 as numbers of sig figs. We lose these, the 377,953, if you can see that. And we can say then this is just taking these two numbers and we can bring back, just put it right back in, times 10 to the minus 8th. Just bring it right back in. And then we put our unit in. It'd be in inches because that was the only unit left. The centimeters had canceled. All right, just a couple things to quickly say. If you use scientific notation, and you can try this, on the TI-30X, you'll actually lose your significant figures because it writes it in standard form and it puts that number all the way over to the right and you can't go further out to see the other figures. So sometimes this trick is just helpful to quickly get to an answer, but also in this case it helps us retain the number of significant figures we need in our calculation. So again, what I did is just took the 1.21, divided it by the 2.54, we got 0.476, and we just brought back into the answer the 10 to the minus 8th. I hope that helps. Thanks. Bye-bye.